Half-a-day students, for today's video, we're going to be going over how to simplify complex rational expressions, which I'll give you an example of in the next slide. This is really just a combination of what we've learned in the past two videos concerning rational expressions. First off, you might have already thought that rational expressions were complex, but actual complex rational expression is one that has more than one fraction bar. An example of this is if I have fractions divided by another fraction. So if I had like 1 over x plus 3 over y over 5 over x minus 2 over y. So I have definitely more than one fraction bar. I have a whole bunch of fractions mixed in there. That's what makes this complex. There are different steps to simplifying. First, you'll just simplify the numerator and the denominator separately. And then from there, you'll divide the numerator by the denominator using the multiply by reciprocal rule. So first off, I'll go into this. Luckily, I only have one fraction on each side, so I'll simplify each of them separately. I might actually write them side by side so it looks like less of a mess. So we have 4b squared over 9a squared divided by 8b over 3a squared. Looking at these, I can actually see that I can't simplify anything in each of these fractions, so I'll just go straight to the multiplication step where I'll flip my second expression there. So I have 4b squared over 9a squared times the reciprocal of my second. So I have 3a squared over 8b. From here, I can simplify pretty easily. 4 and 8, I can reduce that to 1 and 2. B squared and b, I know this b is out because it's a smaller exponent. This will become b to the first power. 3 and 9 can simplify to 1 and 3. And then a squared and a squared, those actually cancel each other out completely, right? So I'm actually left with, I have a b to the first power. So I have b over 3 times 2, which is b over 6. So as you can see, if I have one fraction divided by another fraction, this is actually just what we've learned last class, so it's very simple. Another one here, similar problem. I might use blue now. So I'm going to write it separately first. So we have 3a cubed over 5b squared divided by 6a squared over 10b to the third power. From there, I can actually simplify a bunch already. 6 and 10, I know will simplify to 3 and 5. From there, I'll just change this to multiplication. So I'm going to multiply by the reciprocal, right? So we have 3a cubed over 5b squared times 5b cubed over 3a squared. And if you simplify this in the beginning, if you didn't simplify it in the beginning, you can actually just simplify it all in the end. That's fine too. So whichever way works for you. Sometimes I like to just work with smaller numbers in the beginning, but sometimes I might just go straight to flipping it and then seeing from there where I can cancel. So here now I'm looking at what I can cancel out. A squared is canceled out because it has a smaller exponent. This is going to become a to the first power. 3 cancels itself out. 5 cancels itself out. B squared and b cubed. B squared's out. This becomes b to the first power. So I'm left with a to the first power, b to the first power over 1. That simplified just means AB. So if you have nothing in the denominator, you can actually just excuse the denominator. But if everything in the numerator cancels out, you need to have a 1 as a placeholder there. So if it was everything in the front canceled out, the top canceled out, and the bottom was okay, it would have been like 1 over AB. But because it's in the denominator, we can get rid of it. So for this example, excuse the typo, I had to change it to 38, it was 39 earlier. So what I'll do is I'll just jump straight to flipping my denominator. Okay, from here I'll actually cancel out what I can. I know 19 times 2 is 38, so I'll actually simplify this to be 1 and 2. Y's I'll cancel out, this one in the bottom, this will become y to the first power. 59 and 40 have nothing in common, so I'm going to actually cancel this. X squared, this will become x to the fourth power. What I have left on each, I have 59 times 2. Once you get here, you can actually cancel up and down if you want. So if it doesn't always need to be crossed, as long as one's in the numerator, one's in the denominator. You could actually cancel this one more time because 2 and 40, what do they have in common? They have in common number 2, right? So this is going to become 1 and 20. If you don't do it in this step, that's fine. You'll just have one extra step of simplifying at the very end. So I'll end up with 59 y to the first power over 20 times x to the fourth. So when we see something like this now, our goal is to make each side be one fraction. So you can do that separately. For me, I tend to do stuff like this separately, but I'll just show you it all together in one just because sometimes we just want to keep it a little bit neater so it's not all over the place. But for you, I suggest maybe doing them separately. It might be easier, but just know either of them is an option. Okay, so I know when I'm adding fractions, I need to find my common denominator, right? So I know that for the top, it's going to be 4. And in order to find this, I have to multiply that 5. And to change this 5 over 1 into something over 4, I'm going to multiply it by 4. Since I multiply the denominator by 4, I'll multiply the numerator, which is going to be 20. And this 3 over 4 stays the same. Then I have 6. Oops. It's going to be something over 8 minus 7 over 8, right? I'm going to multiply 6 by 8, which is going to come out to 48. From here, I'll simplify this. 3 over 4 plus 20 over 4 is going to be 23 over 4 divided by 48 minus 7, 41 over 8. From here, I'll do it side by side. So I'm going to go down here. I'm multiplying by the reciprocal, right? So I have 8 over 41. I can cancel things now. 4 and 8. 2 and 1. So this becomes 23 times 2 is 46 over 41. You can check again if there's anything that you can simplify, but there's not. So this is the final. So combine each side into one fraction using least common denominator and then adding and subtracting. And then do regular division, but from there. Okay, so now we're working with variables in my denominators. So this one I'll practice doing separately, right? So I have 1, use a blue. 1 plus 2 over x. I know my denominator is going to be x, right? Since I multiplied this by x, and what's going to be x over x. X plus 2 over x. So that's for my numerator. for my denominator, one minus 4 over x squared. That's going to be the same as x squared over x squared minus 4 over x squared. I'll combine this to be x squared minus 4 over x squared. So working this equation, I can say this is the same as x plus 2 over x divided by x squared minus 4 over x squared. Now this looks like something that we covered in the last section, right? So now I'm going to be dividing it, but once I see polynomials, I'm wanting to factor. This x squared minus 4, I know I can factor to be x plus 2 and x minus 2. So I'm left with x plus 2 over x, multiplying by the reciprocal, right? So we have x squared over x plus 2 times x minus 2. From here, I can simplify whatever I need to. X plus 2 is gone. Oops, wrong one. X is gone. This becomes x to the first power. Okay, so I'm left with x to the first over x minus 2. Be careful with ones like these. Again, we always want to aim towards canceling things out. So factor and then cancel out what you can. Simplify at the very end again if you can. Looking at our last example, I'm just going to rewrite it. 45 over t plus 25 over t squared over 18 plus 10 over t. So when we're talking about denominators, the LCD is going to be a number that can divide both of the ones that you have, right? So when I look at t and t squared is the lowest number that can divide both t and t squared. So my LCD is going to be t. So for that, I'm actually going to just multiply this t here to the numerator and denominator, so to force it to be t squared. Simplifying this, we have 45t over t squared plus 25t, 25, no t there, over t squared. For this new denominator, I know I'm missing again. I need to multiply this by t, right, in order to get that same denominator. So for the denominator, I have 18t over t plus 10 over t. Simplifying each of these, I'm able to get 45t plus 25 over t squared under one denominator. So we have this 18t plus 10 over t. Then I'm going to bring this over and write it horizontally. I'm multiplying by the reciprocal of my denominator, right? So I'm going to flip this second one. As always, I want to factor what I can. 45t and 25, they're both divisible by 5. 5 times 9t plus 5 over t squared times t over, factoring out 2 from each of these, we have 2 times 9t plus 5. And as always, it's going to factor out really nicely, where I can cancel this. I'm left with, can cancel 1t here, and this will just be t to the first power. So my final answer is just going to be 5 over 2 times t. That's all I had left, right? So sometimes I'll actually highlight this or underline what I have left, and a t. So that's actually it for this lesson and for this topic. Keep in mind that this is actually one of the hardest topics of the semester. So if it's a little bit difficult for you, don't feel so bad. Just keep practicing, do a lot of the practice problems, and I promise that it'll get easier. And As always, if it's not getting easier for you, I'll be available on Wednesdays for questions or help. But just please try to set aside maybe 30 minutes a day or an hour every other day, something like that, to really work on your math. Do a lot of practice problems and checking your answers, just because you want to keep your brain in that math mode, right? The longer we go without doing math, the harder it's going to be. So good luck. Please keep up the good work. I'm proud of you guys with your cooperation and basically just making sure you do what needs to be done, even though we're at a time where it's kind of hard to do so. But yes, good job. Thank you for listening and watching till the very end of this long video. Have a good day.